We're going to start with a simple linear equation with just one variable. Let's say it's 10 equals 5 times x. So my variable is x, and since I have a factor multiplied by x, all I need to do is just to send that factor into the denominator, and my x is going to be a fraction of 10 over 5, which is 2. If I have, let's say, 13 equals 26 times x, how do I find x? I'm going to flip a little bit, and x is going to be, again, 13 stays, 26 goes into the denominator, which will be 1/2, or you can say 0.5. An example of a linear equation could be change in x, where change in x is distance or displacement, equals v times t. Now, if we're after change in x, which is distance or displacement, that's very simple. We will just multiply the two variables. So, for example, if v equals 10 kilometers an hour and t is 2 hours, that's very easy. Our change in x is going to be just v times change in t, 10 times 2, 20 kilometers. Another example, we could say if we're after our net force, which is mass times acceleration, if mass equals 3 kilograms, acceleration equals 5 meters per second squared, then the net force applied to the object is 3 times 5, 15 newtons. We know force of friction, for example, equals mu, let's say it's kinetic friction, times normal force. Let's say normal force is 20 newtons. Mu kinetic is 0.3, then force of friction is just multiplying 20 times 0.3, and it's going to be 6 newtons. All right, that's pretty easy. That's just a straightforward of multiplying. Now, going back to the original equation, what if we are after v? So how would I find v from this equation? I would have to go ahead and make a fraction. Change in x remains where it was, and then change in t is going to go into the dungeon. Net force equals mass times acceleration. How am I going to find mass? Mass is going to be net force over acceleration. If I have force of friction kinetic equal mu kinetic times force normal, then force normal is going to be force of friction over mu kinetic. Change in t is going to be change in x over v. That will be change in t. And same here, if I were to find acceleration, I would do net force over mass. If I were to find mu kinetic, I would do force of friction kinetic over force normal. So that's how you rearrange the formula to figure out one of the variables. What if the formula that you were given looks like this? V equals change in x over change in t. Think about it this way. 5 equals 10 over 2. So if I were to think of 2, I could rearrange this as 2 equals 10 over 5. So when you're looking for something in the denominator, you can swap the two. So from here, you can say that change in t is going to be change in x over v. So going back to example, let's say that my displacement is 120 kilometers, and my v is 60 kilometers an hour. How can I find the time that it will take me to travel 120 kilometers at 60 kilometers an hour? So formula is, again, change in x over change in t, from where change in t is going to be change in x over v. You are welcome to stick to your formula like this and work with numbers first. You would say 60 equals 120 over change in t, swap, and that gets your change in t is 120 over 60, 2 hours. As you get more comfortable with variables in the forms of letters rather than numbers, you can go straight to change in t equal 120 over 60 equals 2 hours. The more you practice with formula, the better it gets. Example again, acceleration was net force, that's Newton's second law, over mass. So if I tell you that acceleration of an object is 5 meters per second squared, and force, net force applied to the object is 20 newtons, how would you find the mass of the object? So if I look at my formula, A equals net force over mass, swap, then mass is going to be net force over acceleration. Mass mass equals 20 over 5 for 4 kilograms. Or you can also do, set it up if you're not comfortable with variables, set it up as is. 5 equals 20 over mass, therefore swap these two. Mass is going to be 20 over 5 4 kilograms. Another example. Let's say that I have mu static. Formula is force of friction. Think about another formula we know. We know mu static equals force of friction static over force normal. How would you find force normal? Force normal from there, you swap these, equals force of friction over mu, and they're both static. So let's say my force of friction static maximum is 15 newtons, and my mu static is 0.3, then what is my Fn? I'm going to take my force of friction, 15, divide by 0.3. It's the same as 150 over 3, so it's going to be 50 newtons. Or you could have done it if you are not comfortable with doing this. Going back to original formula, mu static equals force of friction static over normal force. Then you translate that into 0.3 equals 15 over force normal, swap these two, and then you go into 15 over 0.3, and again that's 50 newtons. So that's when you're looking for something in the denominator. Again, the more you practice manipulating the symbols, the better you will be getting at understanding formula and being able to juggle them. It's okay to start with just plugging in numbers and looking for what you are asked to find. Like in this case, when I used the numbers and then just swapped the denominator with the answer.